Hey everybody. Okay, this is a continuation to my mole lecture. My screencast-o-matic cut me off and I ran out of memory, so I think I've got this straightened out. Okay, so a quick reminder, real quick here. 1 mole is equal to 6.022 times 10 to the 23rd items. And again, those items could be atoms, molecules, ions, anything that is very, very, very small. Okay, so first of all, it's easier to work in moles than it is very small particles. 1 mole is going to group this many things, which makes things a lot easier. However, if you are a chemist or even a chemistry teacher, all of our balances are not calibrated in moles. They are calibrated in grams. So if we can make a connection between moles and mass, then it is easier to mix up solutions as a chemistry teacher or as a chemist. So there is something called molar mass. Okay. And the PowerPoint notes are on Google Classroom, but molar mass is the mass in grams of 1 mole of a substance. And that substance can be an element, could be a compound. Those are the main substances we're going to be dealing with. Well, I wish I could get my camera to work a little bit better here for you guys. That doesn't do much for me. There we go. Okay, let's try this. Like I said, my document camera is a little bit different, so let's give this a shot. Okay, so when it comes to the molar mass of a substance, let's start with elements. Okay, molar mass of any element is found on your periodic table of elements. So the molar mass of any element is the atomic weight in grams. Okay, what I want to do is I'm going to use carbon as an example here. Okay, so for instance, 1 mole of carbon atoms, okay, has a mass in grams of 12.01 grams. This is the molar mass, the mass in grams of 1 mole of a substance. I can go over here and I can look at oxygen. The molar mass of any element is its atomic weight in grams. So 1 mole of oxygen atoms is equal to 16.00 grams. Molar mass is always rounded to 2 places past the decimal. Okay, so molar mass is equal to atomic weight rounded to 2 places past the decimal. So every single element on the periodic table, its molar mass is found on the periodic table. Okay. Now, if I was to say, okay, what is the molar mass of carbon? You would say 12.01 grams per mole. So we actually label molar mass in grams per mole, because if I have 1 mole of a substance, this is its mass in grams. So grams per mole. If I have 1 mole of carbon atoms, its mass in grams is 12.01. Okay, so let me show you guys how this actually works, how the atomic weight is actually the molar mass. So let's start with carbon. If we have one carbon atom, its atomic weight is 1.017 AMUs. Okay, that's the weight of one single carbon atom. So I'm going to take that weight of one single carbon atom and I am going to convert that one single atom, its mass or its weight, into grams. So 1 AMU is equal to 1.66 times 10 to the negative 24th grams. So this is the weight of one carbon atom in AMUs, and I'm going to convert that into grams. So 12.0107 times 1.66 times 10 to the negative 24 will give me a mass of 1.99378 times 10 to the negative 23rd grams. So each carbon atom has a mass in grams of 1.99378 times 10 to the negative 23rd. That's one single atom, okay, of carbon. So if I was to take this mass of a single carbon atom, and if I was to multiply it by 6.022 times 10 to the 23rd atoms, okay, what I'm going to do is I'm going to figure out what is the mass of all of these atoms. If every single atom has this mass, if every single carbon atom has this mass, and I have this many atoms, we are going to figure out the mass in grams of this big bunch of atoms. So 1.99378 times 10 to the negative 23rd times it by 6.022 times 10 to the 23rd. As you guys can see, that will give me 12.01 grams. So this is 1 mole of carbon atoms. If each carbon atom has this mass, then the mass of 1 mole of carbon atoms is 12.01 grams. That's how we get to that number. So it's not kind of a coincidence that it's the same as the atomic weight, but for ease, that's what we actually do. We take the atomic weight and label it as grams, and that's the mass of 1 mole of a substance on the periodic table, aka the molar mass. Now let's look at finding the molar mass of compounds or molecules. Okay, and again, this PowerPoint is on Google Classroom. So if we want to figure out the molar mass of compounds and molecules, we're going to add all the molar masses of all of the atoms of each element in the compound or molecule. We're going to add it together. I'm just going to show this to you. Again, this PowerPoint is on Google Classroom. You can go back and write more things down. So if I want to find the molar mass of water, and the video showed you just a little bit ago, the TED Ed video showed you guys that molar mass of water is 18.02 grams. So let me show you how they came up with that. So we have hydrogen and we have oxygen. We have 2 hydrogen atoms. We need the molar mass of hydrogen. So I'm going to come over here, I'm going to find the atomic weight, and I'm going to round that to 2 places past the decimal, which is 1.01. So I've got 2 hydrogen atoms, each with a molar mass of 1.01. I have 1 oxygen atom, and I'm going to go to my periodic table. I'm going to find the atomic weight of oxygen, round it to 2 places past the decimal, and that's 16.00. So 2.02, 16.00. Molar mass is always rounded to 2 places past the decimal. So the molar mass of a water molecule, okay, or I should say molar mass of water molecules are 18.02 grams per mole. This is what this tells you. This tells you if I have 1 mole of water molecules, its mass in grams are going to be 18.02 grams. if I was to do sodium chloride down here, I've got sodium. I only have one sodium atom. Whoa, let's start over. Let's go sodium. I have one sodium atom. Look on my periodic table. Sodium right here. Oh, see if you can see it. 22.99. There we go. 22.99. So 22.99. I've got one chlorine atom. And I got to find chlorine on my periodic table. 35.45. So 22.99, 35.45. I'm just going to add these together. And 22.99 plus 35.45 is equal to 58.44 grams per mole. So we just calculated the molar mass of sodium chloride. So what this tells me is if I have 1 mole of NaCl, then its mass in grams will be 58.44 grams. Okay? And 1 mole of anything is equal to 6.022 times 10 to the 23rd. Let's do one more. Let's do magnesium sulfate right here. So magnesium, I have 1 sulfur and I have oxygen. I have 4 oxygen at 16.00. Again, I'm getting that off the periodic table. I'm going to find sulfur and round it to 2 places past the decimal, so 32.06. And magnesium over here, 24.30. Now I'm going to do the math and add them all together. So 4 times 16 is 64. Plus 32.01 plus 24.30 will give me a molar mass for magnesium sulfate of 120.31 grams per mole. So again, this is what this tells me. If I have 1 mole of magnesium sulfate, its mass in grams is going to be 120.31 grams. So that's the molar mass. So our molar masses are linked between the moles of a substance and the mass in grams, which is going to be helpful when we start doing some conversions.